Hello and welcome. In this video, I want to show you how to do implicit differentiation. Implicit relation or implicit function is when x and y's are mixed up together, like these relations. As you see, in these relations, x and y's are intermixed. Such relations are implicit relations. Now that you know what is implicit relation, let me show you the steps for implicit differentiation. The first step is to differentiate both sides of the equation with respect to x. But when you differentiate a terms involving y, don't forget to multiply it by dy over dx. Take derivative as usual, but tack on dy over dx. By completing this step, actually differentiation is completed. The next steps are for isolating dy over dx. Collect all the terms involving dy over dx on one side of the equation and move other terms to the other side of the equation. Then factor dy over dx and solve for dy over dx. Let's try some examples. X squared plus y squared is 9. We are asked to find dy over dx. The first step is to differentiate both sides of the equation with respect to x. D over dx of x squared plus y squared, d over dx of 9. Derivative of 9 with respect to x is 0. Derivative of any constant is 0. Derivative of x squared as usual is 2x. But the important part is when we take derivative of y squared, we take derivative as usual, but we have to tack on dy over dx. We have to multiply it by dy over dx. So derivative of y squared is similar to x squared, 2y. But you have to multiply it by dy over dx. So we have 2x plus 2y dy over dx equal 0. Derivative of x squared is 2x. Derivative of y squared is 2y multiplied by dy over dx. Whenever you take derivative of a term involving y, multiply it by dy over dx. This is the most important step in implicit differentiation. And derivative of 9 is 0. The rest of the steps are just for isolating dy over dx. We keep the term involving dy over dx in one side and move other term to the other side. We move 2x to the other side. It becomes negative 2x. Now dy over dx is negative 2x over 2y. We don't need to factor anything because we have only one dy over dx. So dy over dx is negative 2x over 2y. If we cancel 2 from numerator and denominator, derivative can be rewritten as negative x over y. Let's make a brief review of implicit differentiation. Take derivative of both sides of the equation with respect to x. After completing differentiation, isolate dy over dx. That's it. Very simple. Let's try some more examples. This implicit relation is given and we are asked to find dy over dx or derivative of the relation. We take derivative of both sides of the equation with respect to x, d over dx of the left, d over dx of the right. Derivative of x cubed with respect to x is simply 3x squared as usual. Derivative of y cubed with respect to x is similar to x cubed, but don't forget to multiply it by dy over dx. Whenever you take derivative of a term involving y, you have to multiply it by dy over dx. Actually, dy over dx plays the role of derivative of the inside function if I want to compare it with chain rule. Anyway, derivative of y cubed is 3y squared times dy over dx. So derivative of the left side of the equation is 3x squared plus 3y squared times dy over dx. The tricky part of this question is derivative of the right side of the equation, derivative of xy. To find derivative of xy, we have to use product rule, because notice that xy is the product of two functions. The first function is x, the second function is y. Let me remind you the product rule. Derivative of f times g is f, the first function, times derivative of second function plus second function times derivative of first function. The first function is x and the second function is y. Write the first function, so we write x. And we have to now multiply it by derivative of second function. Derivative of y, similar to x, is 1. But we have to tack on dy over dx. So derivative of the second function is 1 times dy over dx. But because when we multiply 1 by something, nothing changes, just we write dy over dx. So the first function is x, and the derivative of second function is dy over dx. Plus, write the second function, y, multiplied by derivative of first function. What is the derivative of x? 1. Now the first step is completed, and we have to go to the next step. The next step is to move all the terms involving dy over dx to one side and move other terms to the other side. So we move this term to the left and we move 3x squared to the right. We have 3y squared dy over dx minus, move this term to the left. We have minus x dy over dx equal y times 1 is y, minus 3x squared. If we factor dy over dx, we have 3y squared minus x times dy over dx. And finally, dy over dx is this over that. Y minus 3x squared over 3y squared minus x. This is the derivative of this relation. Another example. An implicit relation is given and we are asked to find dy over dx. If we want to differentiate both sides of this equation with respect to x, we have to use product rule. Note that in the left side of this equation and also in the right side of this equation, we have product of two functions. So if we want to differentiate this relation with respect to x as is, we have to use product rule. But if we multiply y squared in this curly bracket and x squared in this curly bracket, we don't need to use product rule anymore. Y squared times y squared minus 4 is y to the fourth minus 4y squared equals x to the fourth minus 6x squared. To differentiate this relation, we don't need product rule, and more easily we can find derivative of the function. Now we differentiate both sides of this relation with respect to x. Derivative of y to the fourth with respect to x is 4y cubed. We use power rule and we have to multiply it by dy over dx. And derivative of 4y squared with respect to x is 8y. Apply power rule and don't forget to multiply it by dy over dx. So derivative of this relation with respect to x is 4y cubed dy over dx minus 8y dy over dx equals 4x cubed minus 12x. Derivative of x to the fourth is 4x cubed and derivative of 6x squared is 12x. If we factor dy over dx from these two terms, we have 4y cubed minus 8y times dy over dx. And finally, dy over dx is this over that. Dy over dx is 4x cubed minus 12x over 4y cubed minus 8y. If you want, you can factor 4 from numerator and 4 from denominator and write your answer in this form: x cubed minus 3x over y cubed minus 2y. Before I finish this video, let me show you the graph of this implicit equation. This curve is famous to Devil's curve.